Hello and welcome. Today we have an interesting question over here from Mathigon.org. One of my favorite websites because they actually have online textbooks. So none of that boring textbook you have in school, right? It's a really, really cool textbook where you can actually click, interact with problems before they teach you more stuff. So if you're like a secondary school student wondering what higher level mathematics look like, it's actually a very good place to start. So check it out. It's 100% free. We're not sponsored. You're not sponsored by them anyway. So today we're going to instead look at another section of the website where they have puzzles and problems. This is under the 2021 section, question number 9. And the question asks, how many integers, how many whole numbers between 1 and 1 million have a sum of digits equals to 16? Now, if you don't understand what that means, it's okay, right? We can look at, say, the top left-hand corner, this number, 93,211. So if you take 9 and you add 3, that's 12. Add 2, 14. Add 1, that is 16. So we're looking for numbers where if you take the individual digits, sum all of them together, you should get 16. Another example would be the number right smack in the center over here. So you can take a look over here. We're looking for numbers like this. So it's probably a good idea if you're interested in this question, right? If it's like, oh wow, this sounds interesting, take out a piece of paper and maybe pencil, try and work this out. It is always more satisfying if you work this out yourself. Even if you don't get the correct answer, if you sort of like have the correct steps, you feel a lot better than just to sit down and listen to someone talk forever and ever, right? So another thing is I'm going to go through this progressively, right? I'm going to like drop hints along the way. Feel free to pause at any point and work it out on your own. So let's get started. Now, my first attempt at this problem is quite what I call a naive attempt. What I did was try to come up with a system that would comb through the numbers and hopefully get me every single number that whose digits sum up to 16. So starting from here, I have starting with one-digit numbers, right? I know there are no one-digit numbers whose digits add up to 16, of course. Now, moving on to two-digit numbers, I have two blanks, so I can put any digit into these two blanks. But the only successful combinations are 7 and 9, 79, 8 and 8, 88, prosperous number, and 97. Yeah, that was quite okay. 3, we have 3 numbers so far. Moving on to three-digit numbers. Now I have 3 blanks over here. Okay, this gets a bit tougher, right? Because I have 3 digits, this was my approach. Maybe I fix the first number, like I fix it as 900. Okay, and then I have 2 blanks over here, which means I could do like 907, 907. I can do 916, 916, 925, 934. So you can sort of see like I'm just, going through all the different combinations that actually works. After 900 will be 800, and then 700, 600, 5, 4, 3, 2, until 100. That's the lowest we'll go. We will not go to 0, because that is actually a 2-digit number. Okay, so as you can see, that was where I stopped. I didn't go to 4, 5, or 6 because it's simply too tedious. But that does not mean that this naive attempt was totally useless. It actually taught us something really important. Now, going back to the 3-digit case over here, when we had 900 and something. This kind of looked to me like I have 2 slots and I'm just distributing 7 beats. Sounds familiar, right? So I have 9 and then I'm just looking at different ways to put 7 beats into 2 boxes. I can put 0 here and 7. Then I just need to transfer 1 beat over to the left, and then it's like a new combination, right? So 1, 6, 2, 5, 3, 4, 4, 3, 2, 5, 2, 6, 1, 7, 0. You get the idea. Now, that got me thinking, maybe we can use combinatorics, permutations and combinations to solve this problem. So how do we do this? Do we use 6 slots? Do we know how to, say, distribute 16 beats into 6 different boxes? Now, the answer is no. We have not learned how to do that. Sort of, not yet. But what we can think about is we can reframe the question. Think about it as just 16 beats in one giant box. I need to put it into 6 different compartments by introducing 5 dividers. So I can say add a divider here. 1, 2, 3, 4, and just for fun, The fifth divider is kind of redundant, right? Well, what this results is I have a number like 3, 3, 4, 3, 3, 0. This is an example of a 6-digit number whose individual digits sum up to 16. So, are you able to reframe this in terms of PNC, combinatorics? Right, so if you talk about 21 slots, you are on the right track. Okay, so why 21 slots? Because I have 16 beats and I need another 5 more blanks to put in the different dividers. So this becomes a very simple question of, hey, how do I choose, spaces out of 21, 5 spaces to put in the dividers? So that's 21, choose 5. If you want to, it's also the same as 21, choose 16. How do I put 16 beats in 21 slots? These two are actually the same numbers. Yeah, but let's do 21, choose 5. Okay. Yeah, and 21, choose 5 will actually give you 20,349. You can use your calculator to work this out. Okay, but will this give us the answer? Is this the final answer? 20349? No. Why is that so? That is because, coming back to the same 16 balls in one big box, I could have, right, using 21, choose 5. This is also one of the combinations, right, where I put all 5 dividers, 1, 2, 3, 4, running out of space, but I hope you get what I mean. I'm putting all 5 dividers right at the end. Then I'll have a number that is 16, right? 16, 0, 0, 0, 0, 0. That is not even a proper number, right? We do not even have 16 as a 1-digit number, yes? So I need to think about cases like this and remove them from my 20,349. So how do we do that? Okay, so how we can do that is, we need to recognize the problem. The problem is, hey, I cannot put in numbers like 10, 11, 12, so on and so forth, up to 16. 9 is fine, okay? So I'm going to look for these numbers where I have 10 or more beats in one single compartment. Okay, how I can do that is, okay, maybe let's think of 10 balls over here. I have 10 balls here. Okay, let me just remove them. Okay, now I have just 6 beats, right? 6 beats in the box, and I want to introduce 5 dividers. So what I can do is I can just randomly put a divider, say maybe here, 1, 2, 3, 4, 5. Okay, and the resulting number will be 0, 1, 1, 3, 1, 0. Okay, then what I'm going to do is I'm going to put the 10 beats into the first one. So the first compartment automatically gets upgraded to an error, right? So it's 10,11310, no such number. Yes. So I just need to run through all the different combinations of this, where I just keep on adding 10 to the first compartment. Do you know how to find out how many ways to do this? That is the same as, right, thinking about 11 slots, right? Why is it 11 slots? Basically, we're just going to ignore this 10 first, right? Let me put this back to 0. Okay, I'm just looking at all the different combinations of putting 5 dividers with 6 beats. That's 11 slots, isn't it? Right? So this becomes 11, choose 5. Or if you want to do 11, choose 6, it's the same. This will give us 462. 462 ways to get wrong numbers, basically. Okay? Then you might ask yourself, hey, wait, how about the cases where we have 10, 11, 12, 13 in the second compartment, or the third compartment, or fourth, or fifth, or sixth? Now, the good way about this is that, the good thing about this method is I could have done this as well. I could have put this 10 in the second compartment, third, fourth, fifth, or sixth. So I just need to take whatever I just found and multiply by 6. This, multiply by 6. Okay, let's do this mentally. That is a 12, and this is a 37, and that's a 27. Okay, so I'm going to get 2772. So my final answer would be taking my 20,349 minus 2,772. Okay, and this will give us 17,577. That is the number of digits, the number of whole numbers between 1 to 1 million whose individual digits sum up to 16. Okay, very, very interesting problem. Yeah, when I looked at this, I had no idea that I was going to use P and C to solve this. I'm glad, I made some mistakes along the way and worked towards the solution. Yeah, this is what mathematics is all about: making mistakes and finding ways to solve them. Okay, I hope you managed to solve this or get something similar to this and you found this interesting. So until the next video, I think I'll catch you on the flip flop.